Hello, this is Professor Broker, and this is your third lecture for Supply and Demand, Chapter 4. And let's get going. We've been talking about supply and demand. We've been talking about equilibrium, price, and quantity. Okay, we talked about things that don't shift the supply or demand curves, like price. Price moves us along an existing demand curve. These are some things, though, that some non-price factors that can actually shift our demand curve, shifting it, increasing it to the right, or shifting it left because of a decrease. And then, of course, here's our list of things. The price changing does not shift our supply curve, right? It moves us up or down along our existing supply curve, but these are some things right here. This is our list of things that can shift our supply curve, increasing it to the right or decreasing it and shifting it to the left. Now, we need to apply those to our market where we have price on the vertical axis, where we have quantity on the horizontal axis, and where we have an upper sloping supply, a downward sloping demand, and we start off in equilibrium. Now, we know, okay, input costs might shift our supply curve, okay? But what does that then do as an end result to our new equilibrium price and quantity? That's what we want to talk about next. There's a three-step process we want to follow for any of these problems. If there's a problem in your homework, if there's a problem on the exam, if you see something in the real world, this is the three-step process that would be good to use to determine the effect of any event on price or quantity. Okay. Step one, decide whether the event shifts the supply or the demand curve. Okay. Sometimes it's both. In many of our examples, it will only be one of them, but in some it will be both. Okay. Decide in which direction does the curve shift. Does it increase demand? Right? Well, then it will shift it to the right. Does it decrease demand? Then it will shift it to the left, and so on. And then step three, use your supply and demand diagram to see how the shift affects and changes the equilibrium price and quantity. Let's go ahead and apply this to an example. The market for hybrid cars. Okay, here we are with our price on the y-axis, quantity on the x-axis, price of hybrid cars, quantity of hybrid cars, downward sloping demand and upward sloping supply. We start off in equilibrium. This is a snapshot. Okay, now controlling for other factors, anything else that could change, we're going to assume that there's an increase in the price or the cost of gasoline. Okay, now that is not the price of the good we're looking at, right? We're looking at the market for hybrid cars. So this is going to be an exogenous impact, okay? Gasoline costs go up, okay? Now, let's think through this. Step one, which curve would most likely be affected? Well, it's unlikely to directly affect increasing gas prices, unlikely to directly affect the supply decision or the supply curve. But think about demand, right? When are hybrid cars most appealing? In fact, what feature of hybrid cars makes them appealing? The fact that they save you gas money, right? They use less gasoline. So if gas prices are going up, we would anticipate all of a sudden the tastes and preferences towards hybrid cars, or I should say tastes and preferences will shift towards hybrid cars. Just like when gas prices are low, we would anticipate tastes and preferences shifting towards SUVs and trucks. Okay, when gas prices are high, consumers shift preferences towards more fuel efficient hybrid cars, right? So the demand would be affected. If demand's affected, right, and tastes and preferences shift in that direction, then the demand would increase, right? Shifting it to the right. So we would have a parallel shift to the right. This is step two. Okay, again, supply isn't affected. Okay, step three, we need to find the new equilibrium price. Where is it? It's where the new demand curve intersects the old supply curve. So it's up here, right? You can already see that we're going to have everything else constant. Because of this increase in demand, we would expect higher prices for hybrid cars and more quantity of hybrid cars in the market. Okay, that's what we would predict. That's what we would anticipate, and that's what would likely happen in this market because of an increase in demand, controlling for other factors. That is. Okay. Now, when the price, so you might ask a logical question, which is, okay, the demand increased, right? We had a shift in demand, right? That's why this new red curve. But there's also an increase in the quantity of hybrid cars. If supply didn't change, where did these new hybrid cars come from? Okay, because we have a higher equilibrium quantity, which means that there's more hybrid cars bought and sold. Okay, that's a good question. What happens is the increase in demand, right, bids up the price of hybrid cars. As the price gets bid up, just like in our tutoring example from lecture 1, right? As the price gets bid up, that encourages some suppliers to either enter the market or maybe current suppliers to supply more of the product, more hybrid cars in this case, because it's more profitable. So as the price gets bid up, that increases quantity supplied, shown as a movement up along our existing supply curve, okay, because it's caused by the increase in price, which was caused by the increase in demand. So we do get more hybrid cars, we do get an increase in quantity supplied, okay, but because it's caused by a change in price, we don't need a new supply curve. We simply move up along the existing one. Always be careful to distinguish between a shift in a curve and a movement along the curve, okay, very important. So notice again that our demand curve increased. This was a change in demand. This was an exogenous impact, a non-price shift. But our increase in quantity supplied, or our movement along the supply curve, was a change in quantity supplied caused by the increase in the price in this market. Okay? And so this is a good example to keep in the back of your mind as you're working through problems in your homework as well as on our exams. Remember our three-step process. Okay? Now, this, what I'm about to go through the next few slides is just hopefully a helpful analogy to help you think through logically what's going on in these markets, okay? Because some students, I start drawing the curves, I start talking about changes in demand, and I lose them. So I'm going to try to give an example that I think everyone can relate to, all right? Standing in line at a checkout station at a store, say Walmart, Target, whatever, okay? So checkout lines at stores. Everyone, I'm sure, has been in one at some point, okay? So I want to relate checkout lines and people standing in line to the wait time, or how long you have to wait in line, and that's going to be our price. The checkout line, okay, or not the line, but the checkout counter is going to be our supply, okay? Imagine it's our supply. The people standing in line is going to represent our demand, and our wait time, how long these people have to wait in line to check out, is going to be our price, okay? And so let's think through this logically. Imagine we start out with one checkout counter open and 10 people standing in line, and they have a price of 20 minutes of waiting in line. This is our starting point, our starting equilibrium, okay? Well, then what if I tell you that the store manager opens up 5 additional checkout counters, okay? That would increase our supply, okay? And just think about it logically. Don't think about supply and demand curves. Just think about it logically. Would you, if the number of people stayed the same, 10, and there's more checkout counters, okay, would the wait time go up or down? Clearly the wait time would go down, right? And so you can see here that when you have an increase in supply, you have a decrease in the price, okay? So we're just looking at price right now, not equilibrium quantity. But again, if you ever have trouble on the test or on your homework, think through logically, okay, checkout counters. If the number of checkout counters increases, the wait time goes down. That's the same thing as saying the price goes down. Okay? And of course, vice versa. If we started out with 6 and then the manager reduced it to 1 and the same number of people were in line, obviously the wait time of everybody or the price would go up. Okay? Now, let's have our one checkout counter. Okay? And instead of 10 people waiting in line, what if it goes to 50 people waiting in line? It increases, okay? But the number of checkout counters does not increase, okay? Our supply stays the same. Our demand increases. What's clearly going to happen to our wait time? Our price or our wait time will clearly go up. So whereas supply and price moved in opposite directions, as supply increased, the price decreased, demand and price move in the same direction. As demand increases, as the number of people in line increases, and supply stays the same, then our wait time or our price will increase, and vice versa. If a bunch of these people went home and left the line, right, and we only were left with 2 people in line, then clearly the wait time for those 2 people would be a lot less, right? The price would go down as demand goes down. Okay, so let's apply these to these scenarios. First to this table, right? So a supply increase, as the number of checkout counters increases, everything else constant, that will decrease our wait time or decrease the price, right? And as the number of checkout counters decreases, then that will increase the wait time or increase our price. Everything else constant, okay, as the number of people waiting in line increases, our wait time or our price increases. And as the number of people in line decreases, our wait time or price decreases. So you can see, think through the relationship, right, between supply and demand and price, and these changes in supply and demand and price, by simply using this very simple analogy. Okay, let's look at some real world examples in using this analogy. People are consuming more corn as part of their diets, right? The demand for corn is increasing. Okay, tastes and preferences are shifting the demand curve, but don't worry about shifting it right now. Demand increases. There's more people in line. What does that do to our price or our wait time? It increases it, right? So we would anticipate the price of corn increasing. Next one, used cars were deliberately made unusable and taken off the roads during the cash for clunkers policy. So back in 2009, there was a federal government policy called cash for clunkers, where people could trade in their used cars, get some cash from the federal government that they could use to purchase a new car. Okay, and so, and I'm not talking about the merits of the policy or anything like that, but we just want to look at what potentially happened in the used car market, right? Well, when you traded in these used cars, they still had some miles on them, but they were fitted with some chemicals and things that made the engines literally undrivable, unusable. So the used cars were taken off of the roads. Okay, well, is that demand or supply? Well, clearly that's supply. That's supply being taken off the roads. Okay, so supply is decreasing. So think about our checkout counters and our people in line. If we're talking about supply, and we're talking about checkout counters, and we're talking about decreasing them, that means the number of checkout counters decreases. Well, what will happen to the wait time of everybody in line if the number of checkout counters decreases? It will go up. Okay, and this is actually exactly what research has shown over the last few years, is that in the years after this policy, used car prices actually rose. And again, I'm not talking about the merits of the policy. Maybe there were good reasons, or there weren't good reasons for this policy. But again, we could have predicted this on the front end. When this policy was enacted, we could have said, hey, maybe this will help some people, but this is also likely to increase the price of used cars, which is probably going to disproportionately affect middle income and low income Americans who mostly buy used cars, which is it's what we predicted, and it's exactly what happened. Okay, next one. Fewer people are drinking orange juice and are switching to other options. Well, tastes and preferences are shifting away. This is demand. Okay, demand is decreasing. This is the number of people in line. As the number of people in a checkout line goes down, what happens to price? Price goes down. Okay, so again, we can predict that the price of orange juice would go down as demand decreases away from it. Okay, and then finally, Boeing has implemented new technology that builds their planes faster. This is implementation of technology. This is a supply factor. Okay, this is a supply increaser. It increases supply. As the number of checkout counters increases, what happens to our wait time or our price? It decreases. Okay? So again, we've just thought through logically some of these real world events using our very simple either our three-step process as well as our very simple analogy of checkout counters and people waiting in line to help us determine prices and price changes. Okay? Now, we need to talk about something just at the very end here, sort of a little bit more nuanced case. What happens when both curves shift? Okay, let me give you an example. Say there's increased world demand for corn. Okay, clearly that would affect the demand curve. And there's better farming technology that allows more bushels of corn to be harvested per acre. Okay, well, that would clearly influence the supply curve. And so what happens when both supply and demand change? Okay, well, we still use our three-step process. Step one, this time both curves are affected. Okay, step two, demand is increasing. The technology would increase supply, so both curves shift to the right. Next, we need to determine what happens to price and quantity. We have an increase in supply and an increase in demand. We need to find the new equilibrium, which is where the new supply and the new demand intersect. Okay, right there. Okay, this would clearly increase our equilibrium quantity, right? There would be more corn available in the world corn market, more corn bought and sold. And it looks like prices would go down from P1 to P2. But is that necessarily true? Okay, the way it's drawn, it looks like it. Prices go down, quantity goes up. But here's something else I want to point out. What if I draw it this way? Okay, what if I increase demand and also increase supply this way? In this case, quantity still increases, but notice the price went up this time. What's the difference? The difference is the magnitudes. In the first example, I shifted supply more than I shifted demand. In the second case, I shifted demand more than I shifted supply. Okay? Here's the key. The key is that whenever you shift both the curves, okay, one of the variables of price or quantity will always definitely go up or down. In this case, it's quantity. Quantity clearly goes up. The reason you know that is because when you increase supply, quantity goes up. By itself. When you increase demand, quantity goes up. But when you increase demand by itself, quantity also goes up. So because it increases both times, in either case, you know quantity is definitely going to increase whenever they both shift, whenever both curves shift. Now, what about price? Well, in one scenario, price went down, okay, because the supply effect was bigger than the demand effect, and in the other scenario, the price went up, okay? Well, all that we can say in this case is that the price change is ambiguous. Another word we might see or use is that the price change is indeterminate. In other words, when both curves shift, when you have a change in demand and a change in supply, again, one of these variables, quantity or price, will you will be able to determine it. It'll either increase or decrease. The other one will always be ambiguous. Okay? Sometimes it'll be price that's ambiguous. You don't really know if the price will go up or down because it'll depend on the magnitude. Sometimes it'll be quantity that's ambiguous. Right? So for example, if I increase demand but decrease supply, okay? If you think through it, that will increase price but would actually make the quantity change ambiguous. It would be impossible to know the quantity change without knowing the magnitudes. Okay? So that's what you need to know. You need to know that term ambiguous. You need to know the term indeterminate and when to apply it when both curves shift. Okay?